All right, ladies and gents, happy Friday. So day four of exponents, right? We talked about going from radical form to exponential form to radical form. Now we're talking about simplifying radicals. So if you look up here, we have two different answers to the square root of 54. We have 3 square roots of 6, and we have 7.35. That top one is what we call exact radical form. The bottom one is what we call approximate, right? We had to round it because it's really 7.34846922, so on and so forth. This is a rounded number, right? We want the exact form. So what we're going to find out today is we're going to figure out how to find this exact form of a radical. So on the ACT and other math tests, a lot of times we ask to find the exact answer or the exact form. We're going to call it the simplified radical form. Right? Because we want exact answers at all times. We don't want rounded answers. Rounded answers throw things off. They make bigger mistakes down the road. So we're going to use exact radical form. So an example of that would be if you do the square root of 60 in your calculator, you're going to get 7.75, whatever. We don't want that. The square root of 60 should look like 2 square roots of 15. Right? We need to figure out how do we find that. So from now on, we're going to answer things in exact radical form or simplified radical form. How we do that is we use the product property of square roots. Product property of square root states that the square root of a product, or the square root of x times y, is the same as the product of the 2 square roots. So the square root of x times y is the same as the square root of x times the square root of y. We can break things up, break it down into its factors, and then take square roots of it. And that's going to be helpful when we try and take like the square root of 108. What we're going to do is we're going to try to find the biggest perfect square that's a factor of 108. Well, let's think about it. What's the biggest perfect square that's a factor of 108? Well, in this case, it's going to be 36. So using that product property, I'm going to break it down into the square root of 36. And I know 36 times 3 gets me to 108. So the square root of 36 times the square root of 3. Now you're probably wondering, why does that help us? Well, what's going to happen then is, I can take the square root of 36 and I get 6 square roots of 3. And that's my simplified radical form. Right? So we're looking for factoring into two numbers. One of them has to be perfect square. We're looking for the biggest perfect square. If you don't get the biggest perfect square, it'll still work out. We'll see that later. But the biggest perfect square is 36. 36 times 3, so the square root of 36 times the square root of 3. Well, the square root of 36 is 6. And square root of 3 stays the same because we want exact. We don't want to round anything. So our answer is going to be 6 square roots of 3. Alright? So if we practice a few more, the square root of 75. Well, the biggest perfect square that goes into 75 is 25. So I'm going to make it the square root of 25 times the square root of 3. Right? 25 times 3 should give me 75. When you break it down, you should be able to multiply those two back together to get you 75. Well, the square root of 25 is 5. The square root of 3 I can't do because it gives me a nasty number. So that's my answer, 5 square roots of 3. Alright, same thing, square root of 125. Take out the biggest perfect square. In this case, it's 25 again. Square root of 25 times the square root of 5. Well, square root of 25 is 5. And the square root of 5 stays the same because it's not a nice number. So we're taking that biggest square root, we're breaking it out, figuring out what the factor it is with it. That gets us to our original number. Alright, square root of 80. So if, per se, you don't get the biggest square root to start with, let's try it. So let's say we just take out the biggest perfect, or this one of the perfect squares, which is 4. All the square root of 4 and the square root of 20. Right? Well, the square root of 4 is 2, and I have the square root of 20. I can notice, I can still take a perfect square out of 20. It has a factor that's a perfect square. So now I'm going to do that. 4 comes out of it again, and 4 times 5 gives me 20. So now I get 2 times the square root of 5, which is 4 square roots of 5, and that's my final answer. So if you don't get the biggest perfect square the first time, that's fine. Just double check if you can take another perfect square out of it. If you did get the biggest perfect square the first time, you would have got the square root of 16 times the square root of 5, which equals 4 square roots of 5. Right? And that would be our answer. It's the same exact answer. We get to the same exact place, but we started in two different spots. So it's easier if you get the biggest perfect square. It cuts down on a lot of writing, but it's not pertinent that you get the biggest perfect square. Alright, 72. So 72, the biggest perfect square is going to be 36. Square root of 36 times the square root of 2. 36 times 2 gives me 72. Well, square root of 36 is 6. And I'm left with the square root of 2. Right? So we want that simplified radical form. We want to break out the biggest perfect square and its factor and simplify it as much as possible. Alright, there's some for you to try. Pause the video. Try them. When you're done with them, start the video again. I'm going to take the shade down and you can check all your answers. First one should be 9 square roots of 2. Second one should be negative 50 square roots of 7. Right? That negative 5 stays out front. Once you pull the 10 out, it becomes negative 50. Negative 5 times 10. On the bottom, this one should become 24 square roots of 2. This one should become 108 square roots of 3, right? 9 stays up front, so I pull the 12 out. 9 times 12 gives me 108 square root of 3. Alright, so if you need to pause it and look at them at all, pause it, look at the problems you got wrong maybe, and fix them. That's the bottom 2. There's the top 2. Alright, so next thing we're going to talk about, multiplying radicals, right? The product rule. The square root of a times the square root of b is the same as the square root of a times b. We just talked about that product property, right? So what I'm going to say is if there's ever multiplication with radicals, do the multiplication first, then try and simplify the radicals in a simplified radical form. So like here, what we're going to do is we're going to take what's underneath the radical, and we're going to multiply them together and put it under one big radical. So we have square root of 5 times square root of 30. I'm going to make that the square root of 150, because 5 times 30 will give me 150. Then I'm going to take the simplified radical form from there. Break it down into its biggest perfect square. So 25 times 6 will give me to 150. Well, take the square root of 25 is 5. Square root of 6 stays alone because I can't take it. It's not nice. There's no other perfect squares that come out of it. Boom. That's my answer. The next one here. 3 square roots of 2 times the square root of 8. We are only multiplying what's under the radical in this one. Right? There's no other whole number to multiply 3 by, so it just stays out front. Becomes the square root of 2 times 8, which is 16. Well, the square root of 16 is 4, so I get 3 times 4, which is 12. It's okay to get a whole number answer. That's actually really great. Won't always work, but sometimes we do get whole numbers. Our last one, we do have whole numbers to multiply. So we're going to multiply the whole numbers. 3 times 5 gives me 15 times the square root. 8 times 27. Right, so square root of 8 times 27 should be 216. So I get 15 times, and I want the biggest perfect square that comes out of 216, which in this case is 36. 36 times 6 will get me to 216, and I can simplify from there. 15 times 6 times the square root of 6, right? The square root of 36 is 6. So then we should get 90 square roots of 6. And that's my final answer. Get it as simplified as possible. Take out as big a perfect square as you can. Alright, that was multiplication. Now the quotient property. Right? Quotient property square root states that the square root of x over y is the same as the square root of x over the square root of y, and vice versa. You can go either way with this one. Same thing with the product property, you can go either way. And we're actually going to use it both ways. So, highlight it, circle it. So let's start out by doing it. The biggest thing here is we're trying to break it down so we can get perfect squares and we can take square roots of them. Well, in this case, we can't take the square root of 11 over 16. Just doesn't work. So what I'm going to do is I'm going to make it the square root of 11 over the square root of 16. Well, I can't take the square root of 11. So I'm just going to leave it, just like we did before. We don't want to make any decimals. We don't want rounded numbers. It's going to be over, well, the square root of 16 is 4. That's my final answer. Alright? So if it doesn't come out to a nice square root, keep that simplified radical form if you can. In this case we can't, just square root of 11 stays the same. Square root of 16 becomes 4. Alright, now what I'm going to tell you. Problems like this. If you can simplify under the radical first, do it. If you can simplify under the radical first, do it. I can take a 5 out of both of these. It becomes the square root of 16 over 9. Right? If I take a 5 out of 80, I get 16. If I take a 5 out of 45, I get 9. Simplify your fractions first. Alright. Then I'm going to break it down into 2 separate pieces. Square root of 16 over square root of 9. Well, we all know square root of 16 is 4. We all know square root of 9 is 3. Right, so using our quotient rule, we're able to break it down into two separate parts and easily take the square root of them. Alright, a couple more. We have the square root of 40 over the square root of 90. Well, simplify it first. Take a 10 out. It becomes square root of 4 over 9. Then use that quotient property. Break it into two separate square roots. Square root of 4 over square root of 9. Well, square root of 4 is 2. Square root of 9 is 3. That's our final answer. Alright. Last one, square root of 72 over 6. This one, we cannot reduce. You can't reduce 72 over 6 because 6 isn't under the radical. What we can do though is we can simplify this radical up top using simplified radical form. Right? Pull out the greatest perfect square that goes into 72. Well, that's 36. I get the square root of 2. But it's still over 6. Right? Keep simplifying it. Square root of 36 is 6. Square root of 2 over 6. Lastly, now we can simplify. We have something outside the radical. It's the same for both of these. 6 and 6 cancel. I get square root of 2 over 1, or just square root of 2. Alright? So if they're not under the radical together, we can't simplify them. No way. Alright, once again, I want you guys to try some problems. Pause the video. Try the, was it 4 problems, I think? 4 problems. And I'll put the answers up here. You can pause them, check your answers as you go. Alright, so pause it, try the problems. Your first two, you should get square root of 7 over 10. Right, break it down in two parts. Square root of 100 is 10. Second one, break it in two parts. Square root of 49 is 7. Square root of 16 is 4. We get 7 over 4. Bottom two. Reduce your fraction first, right? This reduces to 49 over 100. Break it down. Square root of 49 over square root of 100 gets you 7 over 10. Last one over here, square root of 32 over the square root of 2. Go that other way. Go the opposite way. Put it all under one square root. And then simplify it. 32 over 2 becomes 16 over 1, or just 16. And the square root of 16 is 4. So you can work both ways with that quotient property and the product property. Alright, homework time. Finish your homework. Have a wonderful weekend. Make good choices.